Welcome back to my YouTube channel. In this video, I want us to solve a question in mole concept, which involves the calculation of number of moles, especially the limiting reagent. So the question reads, 2.0 grams of pure magnesium ribbon reacted with exact 300 cubic centimeters of 2.0 mole or per decimeter cubic of hydrochloric acid. So this is the concentration is given, and the volume. We also have been given the mass of magnesium. Okay, so the first question A, construct a balanced chemical equation for the reaction. Include state symbols. So we construct the balanced chemical equation. So here, magnesium reacted with the dilute hydrochloric acid. So we need to react magnesium. So for A, magnesium plus hydrochloric acid which is giving us okay, so hydrochloric acid which is giving us magnesium chloride plus hydrogen gas. Okay, so if you don't know how to write chemical equations, you need to check for the video which I had posted earlier on. I taught about how to write the chemical equation as well as formulas of this compound. Now the question is write a balanced chemical equation including state symbol. So we need to balance. We have one magnesium, one magnesium is balanced. We have two chlorine, here we have one chlorine. So to balance this, we have to we're going to put a 2 in front of hydrochloric acid, then it has balanced because we have two hydrogen, we also have two hydrogen. So that is balanced. Includes state symbols. Magnesium, it is in solid state. Hydrochloric acid, it is in aqueous state. Then magnesium chloride, which is a soluble salt, is also in aqueous state, and this is a gas. Question B, determine the limiting reagent for the reaction. Okay, determine the limiting reagent. So the first step when determining the limiting reagent is writing the balanced chemical equation, which we have already. So I'm going to change this. It's going to be our B. So we have the balanced chemical equation. Then the second step is calculating the number of moles for a substance whose mass or volume or whatever is given. So in this case, we have the mass of magnesium. We need to find the number of moles for magnesium. So the second step, first step is done. Second step, we find the number of moles for magnesium. So mole is equals to mass over the atomic mass. So this is magnesium. So mass over the atomic mass. So the mass of magnesium, in this case, we have been told it is 2 over the atomic mass of magnesium. If you check on the periodic table, is 24. So you divide 2 by 24. So we have 2 divided by 24, giving us 0.0833. So this is giving us 0.0833. Okay. So that's the number of moles for magnesium. Now again, we want the limiting reagent between the hydrochloric acid as well as the magnesium. So we can still find the number of moles for hydrochloric acid because the volume has been given. So let us find the number of moles for hydrochloric acid in terms of concentration. So concentration is equals to the number of moles over the volume of a substance. Concentration is equals to number of moles over volume. Moles over volume. So here, concentration is given, which is 2. So concentration is 2, which is equals to the number of moles given, which is also, the moles we don't know is the one we are looking for. So moles over the volume of this acid, which is 100 cubic centimeters. So you raise this one as a fraction, you cross multiply. So the number of moles for this acid is equals to, so that is 2 times 100, which is giving us 200 moles. Okay, so we have used the formula for concentration. Concentration is equals to moles over volume. Okay, just forgot something. You're supposed to convert this volume into decimeters because the concentration is in mole per decimeter cubic. So you need to convert this 100 into decimeter cubic. Okay, so we have 1 decimeter cubic is equals to 1000 centimeters cubic. What about the 100 centimeters? how many decimeters is there? So which will mean that you need to divide 100 divide by 1000. 100 divided by 1000, which is giving us 0.1. So the volume is 0.1. So instead of using 100 here, we have to use 0.1. Okay, so we have 0.1 that side. You raise this as a fraction and cross multiply. So the moles is equals to 0.2. When you multiply 0.1 times 2, so 0.1 times 2, we're getting 0.2. So the number of moles for the acid is 0.2. Now we have the number of moles for the magnesium. We also have the number of moles for the acid. So what we need to do now is writing the mole ratio between magnesium as well as this hydrochloric acid, the mole ratio between magnesium and the hydrochloric acid. So in this case, we have magnesium this side, then we have hydrochloric acid the other side. You check the number of moles for a substance which is from the balanced chemical equation. So the number in front of magnesium is 1, the number in front of chlorine, hydrochloric acid is what? Is 2. Now we need to compare this ratio. So we need one mass of magnesium to 2 mass of what? Of chlorine for this reaction to balance. So we need to know which one is the limiting reagent. Okay, so what you're going to do is we have the number of moles for the magnesium, we also have the number of moles for the hydrochloric acid. So we start by having the number of moles for magnesium, which is 0.0833. So we compare these two. So we say, what's the number of moles for magnesium? So number of moles for magnesium over the number of moles for hydrochloric acid. Now remember, if you compare these two, which will be, this is the same as 1 to 2, which is giving us 0.5. So this is the same as 0.5. Okay, so which means that we need about 0.5 moles of magnesium for us to do the, for this reaction to go to completion without any of these being limited. So now let's try to compare. What's the number of moles for magnesium? Magnesium has 0.0833 over the number of moles for hydrochloric acid, which is 0.2. So we divide this. We have 0.0833 divided by 0.2, giving us 0.4165. Now remember, we are saying that we need 0.5 moles of magnesium for this reaction to go in completion. Now, in the actual equation, we only have 0.4165, which is not this. So if this number is less than the mole ratio there, then this substance is what? Is the limiting reagent. So in this case, magnesium is the limiting reagent, because when you compare the mole ratio for their number of moles and the numbers in front from the balanced chemical equation, they are different. So from the balanced chemical equation, we need 0.5 of magnesium, but from the chemical equation, from what you calculated there, it is giving us 0.41. So this number is less than this, therefore this is in what? This is a limiting reagent. If one can do the same thing for chlorine as for hydrochloric acid as well, you can say, okay, hydrochloric acid over magnesium. So in this case, this becomes 2 to 1. This is 2 to 1, which is the same as 2 over 1, which is giving us what? The 2. So what's the number of moles for hydrochloric acid? Is 0.2 over the number of moles for magnesium, which is 0.0833. So you divide 0.2 divided by 0.0833, giving us 2.400. It goes, the number continues to go. Compare again. We need 2 moles of hydrochloric acid for this reaction from the balanced chemical equation. Now, if we calculate, it is giving us 2.4. It's more than the number which is there. So this number or this compound is in what? Is in excess. So we didn't want to go this far. I just wanted to do the same equation, the same calculation for hydrochloric acid. So in this case, the limiting reagent is magnesium. So the limiting reagent is magnesium there. Okay. Calculate the volume of the gas that was evolved at RTP. Calculate the volume of the gas which was evolved at RTP. So to calculate the volume, we need to calculate the number of moles for a substance whose mass or volume is given. So in this case, we're just going to use magnesium. We don't want all this part. We're just going to use magnesium. So we have the number of moles for magnesium. So since we're looking for the number of moles for hydrogen gas, then you have to write the mole ratio in terms of magnesium, whose number of moles is known, and the substance which we want. So we have magnesium to hydrogen gas. The number in front of magnesium is 1. The number in front of hydrogen gas is 1. The number of moles for magnesium is 0.08. Let's just get this. Then if the numbers in front are the same, it means they have the same number of moles. So even hydrogen gas has 0.08 moles. So the number of moles for hydrogen and magnesium is the same. Okay, so what you're going to do here is finding the volume now at RTP. So number of moles is equals to volume of a substance over the molar volume. Now, what's the number of moles for the hydrogen gas? The number of moles is 0.08, which is equals to volume, what you are looking for, over the molar volume at RTP, which is 24. Okay, the molar volume at RTP is 24 decimeter cubic. So raise this one as a fraction, you cross multiply. So we have 0.08 times 24. So 0.008 times 24, which is giving us 4. Okay, let me just multiply again. 0.08 times 24, giving us so giving us 1.92. So volume is equals to 1.92 decimeter cubic. Okay, so the volume of the gas which was evolved is 1.92 decimeter cubic. Thank you so much for watching. If you have more questions, you can kindly leave them in the comment section below, and I'll be gladly to respond to your questions. Please make sure you subscribe to my YouTube channel so that whenever I post a new video, you'll always be notified. Thank you so much. Have a good day. Bye bye.